Hi everybody. In this video I'm going to be talking about my participation in our final project, which is the UFC analytics. So what I did was I participated in creating the graphics using the Python programming language. So let me show you what I did. Here we've imported a couple of packages, the most important of which are the matplotlib, pandas, and numpy. So as we see, this is our first graph, which basically contains the number of UFC fights per year from 1993 to 2015. So what we did here, sns.set is basically a package that we got from Seaborn, and it basically makes the graph look prettier in general. So years underscore df.plot. Years underscore df is our data frame, which basically contains the years from 1993 to 2015 as our x values, and the respectable y values. So that means how many fights took place in 1993, 1994 until 1995. And I plotted this in this graph, and fixed size is basically the sizes of the graph. So in this case it's 10 by 7. plt.title is the title of our graph, which is number of USC fights per year. The PLT X label is basically what we named the x-axis, and the Y label is what we named the y-axis, years and fights. So proceeding to the next graph, we have a slightly more detailed version of the ladder, and it's the number of USC fights per month, again from 1993 to 2015. In a very similar fashion, our fight dates month data frame basically contains the months as the x values, and again its respectable y values, and it's plotted here in this graph. So for example, we can see that in 1994 we have approximately 17 fights in this specific month. And again, the title is this number of UFC fights per month, X label is year, and Y label is fights. And this is a bar graph. It's slightly different from the other ones, and it shows the method of victory in detail. So how did the specific UFC fighters win the specific matches. So the method count detail, it basically contains information of it contains the methods of victory, so unanimous, punches, split decision, and it also has the number of victories in these specific methods. So there might be, 80 victories with unanimous decision, 50 with punches, and this is plotted in this graph. The kind of graph is bar H, where H basically says that the graph is a horizontal bar graph. Legend equals false means that we don't want to show a legend in this specific graph, and fixed size again is the size of the graph. Again, PLT title is the title of our graph, methods of victory in more detail, and the label is number of occurrences, as we can see. And our last 2D graph is again a bar graph, slightly in less detail than the one we just saw. This contains victories by decision, knockout, submission, and others, so disqualification and whatnot. Here our data frame contains not as much information as there is here. It's basically the same thing, just with 4 categories. So in this slightly more difficult graph, we're plotting a 3D graph, which basically consists of 2 graphs. So the first graph is 3D graph, interactive graph of the methods of victory, where one of the axes is the victory by submission, victory by knockout, and victory by decision. And these points that you see are basically are the UFC fighters. So let's go to the code. Here, we basically, this portion of the code, basically we create a graph with sizes 10 by 10, and we say that its projection is going to be 3D, so it's basically going to be a 3D graph. So the first case that we look at is if it's a loss graph, so it's a methods of defeat graph. So if it's a methods of defeat graph, we say that we want to create a graph which is a scatter graph, and this 3D graph is a scatter graph, as we can see. We create a scatter graph, and basically what we do is we go through these categories in our data sets: losses by decision, losses by knockout, and losses by submission, and with a 4 cycle, and we retrieve their respectable values, and we turn them into float numbers. So by doing this, we basically put the points on the graph. Next, here what we did is we try to make every point have a different color. So the further away our points are from the origin, the 0, 0, 0 point, the brighter the point is. And what we did here was we counted the norm, which is basically the distance of the given point from the 0, 0, 0 point, and the number that we get from that point, it basically represents an individual color. So as we can see, in a very similar fashion as here, we go through each of the values in these 3 categories, we get their numbers, and we count their distance from the origin point. And like in this fashion, we get the individual colors of our fighters. And s equals 20 basically just means that we want the size of the points to be of size 20. And in a probably identical fashion, not probably, in an identical fashion, we get the graph for methods of victory. So this is methods of victory. In a very identical fashion, we get this graph. As we can see, it's an interactive graph. We can look at it from basically any angle that we wish. And on an analytic point of view, the further away a fighter is from the origin point, so basically the brighter it is, we can basically say that that specific fighter is better, because that means that he's better at a specific fight art. So if you're higher in the victory by submission section, that means you're good at submissions, and so on. And here we basically set the axis names: the X label, defeat by decision, in the case where we look at the loss graph. The Y label would be defeat by knockout, the Z label would be defeat by submission, and finally the title of our graph would be, in that case, would be methods of defeat. So here, let me quickly show you how the graph would change if we look at the methods of defeat. And we have a different graph here, which is already shows us the different methods by which fighters have been defeated. So this is my portion of our project. Thank you for watching this video, and I hope you enjoyed.